All right, in 4.1, we've been looking at triangle types. What we're going to look at now is how to take some of those triangle type definitions, turn them into the kinds of problems we're going to be solving. So in this case, I have triangle PQR, and it's defined as an equilateral triangle. Now, if you remember from your definitions, an equilateral triangle is a triangle where all three sides are congruent. Now, the picture doesn't show that in that nothing is marked. So the first thing I want to do before I even attempt to do a problem is I'm going to take the definition as provided here. I'm going to add these hash marks or tick marks to the segments to show me they're congruent. Now that's going to help me later as I figure out where to go with all of this. Now, based on that, I can see that these expressions are going to equal each other. So if the question is what are the sides of the triangles, I'm going to be looking to use these expressions. Now, I only need to put two of them equal to each other. There are two sides in an equation, so I'm going to take things from one side and put it on both there. So I take 3x minus 4, for example. And I can set that equal to, say, about 2x plus 3, the side over here. So I'll put that here, 2x plus 3. Now I can solve that equation. Now I could pick any two of these sides to match up because it's equilateral. All three are equal to each other. So let's do the algebra. Subtract 2x from both sides. Leaves me x minus 4 is equal to 3. Add 4 to both sides. X is equal to 7. Now that doesn't actually tell me how long all the sides are. That simply tells me what the variable would be if they all match up. Now what I'm going to do is I'm going to take that 7, plug it back into one of the expressions. Since all three sides are congruent, all three of them are going to give me the same answer. I'll take this 3x minus 4. So I'm going to do 3 times x minus 4, so that's 21 minus 4 puts me at 17. As a check, I can substitute into all of these. How about 15x minus 18? 5 times 7, that's going to be 35, minus 18 puts me back at 17 again. So I can see that I'm consistently getting 17 for the length of all three sides. The real challenge in these problems is going to be to use the information provided in the problem in order to come up with an equation that you can solve. Now, unlike what we were doing in chapter 1, where we did the part plus part equals whole equation, here we're generally looking for things that are congruent that we can set equal to each other. Either angles that are congruent, because we're talking about an equiangular, or an isosceles triangle, or segments we can set equal to each other, like in an equilateral triangle, or another isosceles triangle. All right. All right, now let's take a look at a longer story problem. Here it says a jeweler is bending metal into equilateral triangles, which are 6 inches, that's what the two tick marks, on a side. How many can be made with 12 feet of wire? Now we've got a little bit of work ahead of us here because we've got a mix of units. That's going to happen from time to time and you have to be on the lookout for it. So always make sure that when you're working through these problems you're using the same units all the way through. So before I begin, let's take that 12 feet and convert it into inches. That will help guide our work. So we have 12 feet worth of wire times, I'm going to use a fraction for my unit conversion. There's 1 foot represents 12 inches. And I want to be sure that the units cancel. And I'm actually going to use the 2 tally marks to represent inches as a reminder. So feet cancels feet, gives me 144 inches of material that I'm going to be working with. The other reason this particular problem works into what we're talking about is the use of the word equilateral. Now, an equilateral triangle, as we've talked about in other examples, is a triangle where all three sides are the same length. Not to be confused with equiangular, which is a triangle in which all three angles, angular angles, are the same. So, equilateral triangle means I have a triangle that's going to be 6 inches on each side. So how much material am I using when I make that? If I add up all three of those sides, each triangle represents 18 inches worth of material. So now what the question really is asking, how many times can I evenly divide 18 inches into my 144 inches worth of wire. And that's a classic problem we did back when we learned division. So I'm going to set that up now by saying I've got my 1444 inches, divide that by 18 inches per triangle. Let's see what we get for a number. I'm pretty sure I'm going to end up with a decimal here. And let's be sure. My pre-iOS 7 update. Let's see, 144 divided by 18. Oh, works out to be an even 8. Eight triangles exactly. And then we're done. Now, you also want to be careful because just like when you learned division in the first place, if this had worked out to be a decimal, so let's say for argument's sake I got a number like 8.3. I wouldn't say I can make 8.3 triangles. I would say I can make 8 triangles because I just have some wire left over when I'm finished. Be on the lookout to make sure that your answers make sense for the story you're reading. Just like with some things, distances won't be negative because you can't go a negative number of miles. Certain things will always have to be whole numbers because that's what the story is referring to. All right, take a look at some of these next time we're all together.